Hello everyone. Today let us discuss about 5G. 5G is the fifth generation mobile system promising ultra fast speeds, super low latency and massive device connectivity. In this video, we will explore the cutting edge world of 5G by discussing its key objectives, the frequency bands it operates on, the revolutionary services it enables, its innovative architecture, and the critical security and privacy measures it employs. In the introduction to 3GPP technologies discussion video, we have seen various 3GPP technologies such as GSM, Global System for Mobile Communications, UMTS, Universal Mobile Telecommunications System, LTE, Long-Term Evolution, and 5G, and how these technologies are advancing mobile communications. In our previous videos, we started our discussion around GSM, followed by UMTS, and then LTE. So today let us deep dive into 5G. Let us look at the key objectives or contributions of 5G mobile communications. Starting with wireless infrastructure to connect the world. Due to unprecedented adoption of mobile devices, the importance of mobile connectivity is becoming similar to that of access to electricity. Broadband connectivity acts as one of the key pillars to enable mobile service delivery and information exchanges. New ICT market, integrated information and communication technology to drive economies around the globe. As an example, the accumulation, aggregation, and analysis of big data to deliver customized networking services for enterprises and social network groups in wireless networks. Bridging the digital divide. 5G to help closing the gaps caused by an increasing digital divide. Affordable, sustainable, and easy to deploy mobile and wireless communication systems while effectively saving energy and maximizing efficiency. New ways of communication. 5G to enable sharing of any type of contents anytime, anywhere through any device. New forms of education. 5G to change the method of education by providing easy access to digital textbooks or cloud-based storage of knowledge on the internet, boosting applications such as e-learning, e-health, and e-commerce. Promote energy efficiency. 5G enables energy efficiency across a range of sectors of the economy by supporting machine-to-machine communication and solutions such as smart grid, teleconferencing, smart logistics, and transportation. Social changes. 5G networks make it easier to quickly form and share public opinions. Opinion formation of a huge number of connected people due to their ability to exchange information anytime, anywhere will become a key driver of social changes. New art and culture enable people to create works of art or participate in group performances or activities such as a virtual chorus, flash mob, co-authoring, or songwriting. People connected to a virtual world are able to form new types of communities and establish their own cultures. Now let us quickly look at usage scenarios of 5G. 5G to expand and support diverse usage scenarios and applications. Enhanced mobile broadband. Mobile broadband addresses the human-centric use cases for access to multimedia content, services, and data. The demand for mobile broadband will continue to increase, leading to enhanced mobile broadband. The enhanced mobile broadband usage scenario will come with new application areas and requirements in addition to existing mobile broadband applications for improved performance and an increasingly seamless user experience. Ultra reliable and low latency communications. This use case has stringent requirements for capabilities such as throughput, latency, and availability. Some examples include wireless control of industrial manufacturing or production processes, remote medical surgery, distribution automation in a smart grid, transportation safety, among many others. Massive machine type communications. This use case is characterized by a very large number of connected devices, typically transmitting a relatively low volume of non-delay sensitive data. Devices are required to be low cost and have a very long battery life. Now let us look at the spectrum or frequency bands supported by 5G system. 5G spectrum is divided into two frequency ranges, that is FR1 frequency range 1 and FR2 frequency range 2. FR1 is also called as sub 6 GHz, which includes frequency bands from 410 MHz to 7125 MHz. These frequency bands provide excellent coverage, penetrate buildings and obstacles more effectively than higher frequency bands while with lower capacity. FR2, also known as millimeter wave, it has two frequency ranges, that is 24.25 GHz to 52.60 GHz, while other range include from 52.60 GHz to 71 GHz. Frequency range FR2 offers a significant bandwidth, enabling extremely high data rates, while it has a shorter range compared to frequency range 1, and it is more susceptible to obstacles like buildings and trees. FR2 is crucial for delivering the ultra high speed and low latency communication, especially in high density environments. Considering 5G is not an evolution technology like its predecessors such as LTE, UMTS, and GSM, but it is a revolutionary mobile system designed to meet customized business needs across various industry verticals. Hence, 5G system to offer a wide variety of capabilities. Now let us look at the list of these capabilities. Starting with network slicing, which allows the operator to provide customized networks. Diverse mobility management. A key feature of 5G is to support the user equipments with different mobility management needs. Multiple access technologies. 5G system will support 3GPP access technologies such as NGRAN, Next Generation Radio Access Network, and EUTRA, Evolved Universal Terrestrial Radio Access Network, as well as non-3GPP access technologies such as Wi-Fi, wireless LAN, WLAN, satellites, among others, to increase coverage and availability. Resource efficiency. 5G introduces the opportunity to design a system to be optimized for supporting diverse user equipments, including sensors and services. Efficient user plane. User plane should be more efficient for 5G to support differentiated requirements. Efficient content delivery. In-network content caching provided by the operator, a third party, or both can improve user experience, reduce backhaul resource usage, and utilize radio resources efficiently. Priority, quality of service, and policy control. 5G network will support many commercial services and regional or national regulatory services with requirements for priority treatment. Network capability exposure. New network capabilities need to be exposed to the third party. As an example, to allow the third party to customize a dedicated physical or virtual network or a dedicated network slice for diverse use cases. Context-aware network. Information gathered by sensors, the utilized access technologies, the application context, and the application traffic characteristics can provide useful information to the applications installed in the user equipment and can also help the 5G system utilize resources in an efficient and optimized way. Self backhaul. Network planning and installation efforts can be reduced by leveraging plug and play type features such as self configuration, self organizing, and self optimization. Flexible broadcast and multicast. A flexible multicast broadcast service will allow the 5G system to efficiently deliver such services. Connectivity models. The user equipment can connect to the network directly, that is direct network connection, or connect using another user equipment as a relay user equipment, that is indirect network connection, or connect using both direct and indirect connections. Energy efficiency. This is a critical issue in 5G. The potential to deploy systems in areas without a reliable energy source requires new methods of managing energy consumption, not only in the user equipments but throughout all the components of 5G system. Minimal service levels. In constrained circumstances, the 5G system shall be able to support a minimal user experience. Extreme long range coverage. The network access everywhere over long distances, including both humans and machines, need to be supported. Multi-network connectivity. 5G system shall enable users to obtain services from more than one network simultaneously on an on-demand basis. 3GPP access network selection. 5G system will support the concept of network slices where different next generation radio access networks potentially are connected to network slices of different service or slice types. Enhanced V2X services. 3GPP system is expected to support various enhanced vehicle to everything scenarios. NG RAN sharing. Increased density of access nodes needed to meet future performance objectives pose considerable challenges in deployment and acquiring spectrum and antenna locations. Radio access network sharing is seen as a technical solution to these issues. Unified access control. 5G system will provide a single unified access control where operators control accesses based on access identities and access categories. QoS monitoring. 5G systems should be able to support quality of service monitoring or assurance for ultra reliable low latency communication services, V2X and vertical automation. Ethernet transport services. 3GPP systems shall be able to support an Ethernet transport service. Non-public networks. Non-public networks are intended for the sole use of a private entity such as an enterprise and can be deployed in a variety of configurations utilizing both virtual and physical elements. Specifically, they can be deployed as completely standalone networks. They can be hosted by a public LAN mobile network, or they can be offered as a slice of a public LAN mobile network. 5G LAN type service. 5G expands the scope and reach of 3GPP defined technologies. There are multiple market segments in the realm of residential, office, enterprise, and factory where 5G will need to provide services with similar functionalities to local area networks and virtual private networks, but with improved capabilities. Positioning services. 5G positioning services aim to support verticals and applications with positioning accuracies better than 10 meters, thus more accurate for location services. Cyber physical control applications in vertical domains. 5G system is expected to meet the service requirements for cyber physical control applications in vertical domains. Messaging services. 5G system is expected to support advanced capabilities and performance of messaging service, especially for massive IoT communication. Steering off roaming. This allows the home public LAN mobile network to steer a user equipment to a visited public LAN mobile network on which the HP element wants the user equipment to register when the user equipment registers on another visited public LAN mobile network. Minimization of service interruption. A mobile network can fail to provide service in the event of a disaster. 5G system with the capability to mitigate interruption of service. User equipments can obtain service if there are public LAN mobile network operators prepared to offer such service. UAV aspects. 3GPP system is expected to support various enhanced uncrewed aerial vehicle scenarios, especially for a wide range of applications and scenarios by using low altitude UAVs in various commercial and government sectors. Video, image and audio for professional applications. 5G system supports the communication services for video, imaging and audio for professional applications. Critical medical applications. 5G system is expected to meet the service requirements for critical medical applications, where critical medical applications denote medical devices and applications involved in the delivery of care for patients' survival. Service function chaining. A service function chain for 5G networks contains service functions such as firewall functions, network address translation, anti-malware, parental control, distributed denial of service protection, TCP proxies, load balancers, key performance indicators monitoring, and video optimization, among many others. 5G timing resiliency. The 5G systems rely on reference precision timing signals for network synchronization in order to operate. Timing resiliency enhancements to the 5G system can work in collaboration with different types of time sources to provide a robust time synchronization. Ranging based services. These are the applications utilizing the distance between two user equipments or the direction of one user equipment from the other one. Personal IoT networks. Personal IoT networks and customer premises networks provide local connectivity between user equipments and or non-3GPP devices. In general, they are owned, installed, and or configured by a customer of public network operator. 5G IMS multimedia telephony. 5G system is expected to support advanced capabilities and performance of enhanced IP multimedia subsystem telephony services to meet new demands from consumers, business customers, and vertical markets. AI/ML model transfer. In mobile communication systems, mobile devices are increasingly replacing conventional algorithms such as speech recognition, image recognition, video processing with AI/ML models to enable applications. The 5G system can at least support three types of AI/ML operations. AI/ML operations splitting between AI/ML endpoints, AI/ML model or data distribution and sharing over 5G system, distributed federated learning over 5G system. Access to local services. Providing access to local services creates new opportunities for users and service providers. Mobile base station relays. A mobile base station acting as a relay between user equipment and the 5G network, that is providing a new radio access link to user equipments and connected wirelessly through a donor NG-RAN to the 5G core. Tactile and multimodal communication service. These services support applications enabling input from more than one sources and or output to more than one destination to convey information more effectively. The input and output can be different modalities, including video, audio media, information received by sensors about the environment, haptic data, can be feelings when touching a service, among many others. Support of roaming service providers. A roaming services provider provides the technical and commercial means to facilitate the deployment and operation of roaming services between a client operator and a set of selected connected operators. The roaming services provider handles the technical implementation of the roaming relations in a scalable and operationally efficient way. Next, when it comes to architecture, 5G system architecture is defined to support data connectivity and services, enabling deployments to use techniques such as network function virtualization and software defined networking. Key principles include separate the user plane functions from the control plane functions, allowing independent scalability, evolution, and flexible deployments. Modularize the function design to enable flexible and efficient network slicing. Defining procedures as services so that their reuse is possible. Minimize the dependencies between the access network and the core network. The architecture is defined with a converged core network with a common access network to core network interface, which integrates different access types. Support for unified authentication framework and capability exposure. And support roaming with both home routed traffic as well as local breakout traffic in the visited public LAN mobile network. When it comes to architecture reference models, 5G architecture is defined as service based, and the interaction between network functions is represented in two ways: a reference point representation and a service based representation. In reference point representation, the interaction exists between the network function services in the network functions described by point to point reference point between any two network functions. A service based representation where network functions within the control plane enables other authorized network functions to access their services. Service based architecture offers greater flexibility, scalability, and future readiness compared to the more rigid and hardware dependent point to point reference architecture. Network functions within the 5G core control plane to use service based interfaces only for their interactions. Now let us look at the 5G system architecture, starting with user equipment. The user equipment consists of the physical equipment used by 5G subscribers, which allows a user access to network services. The interface between the user equipment and the network is the radio interface. Then NGRAN, next generation radio access network. NGRAN consists of a set of G node Bs connected to the 5G core through the NG interface. G node B can support frequency division duplex mode, time division duplex mode, or dual mode operation. G node Bs can be interconnected through the XN interface. A G node B may consist of G node B centralized unit and one or more G node B distributed units. Then 5G core network that consists of following network functions: authentication server function AUSF, access and mobility management function AMF, unstructured data storage function UDSF, network exposure function NEF, network repository function NRF, network slice admission control function NSACF, network slice specific and standalone non-public networks authentication and authorization function NSSAAF, network slice selection function NSSF, policy control function PCF, session management function SMF, unified data management UDM, Unified Data Repository UDR, User Plane Function UPF, User Equipment Radio Capability Management Function UCMF, Application Function AF, 5G Equipment Identity Register 5G EIR, Network Data Analytics Function NWDIF, Charging Function CHF, Time Sensitive Networking Application Function TSNAF, Time Sensitive Communication and Time Synchronization Function TSC TSF, Data Collection Coordination Function DCCF, Analytics Data Repository Function ADRF, Service Communication Proxy SCP, Security Edge Protection Proxy SCPP, Non-3GPP Interworking Function N3IWF, Trusted Non-3GPP Gateway Function TNGF, Wireline Access Gateway Function WAGF, Trusted WLAN Interworking Function TWIF. These network functions, along with some other network functions, form 5G core network. So when we say 5G system, it includes user equipment, NGRAN, next generation radio access network, and 5G core. Then we have public data network. This refers to the public internet where users related services are residing. 5G, considering the packet switched based system, inherently it does not support circuit switched services such as voice and SMS. So 5G relies upon another 3GPP core network called IMS, IP Multimedia Subsystem, to offer these services over 5G. Voice over 5G or voice over new radio is the technology being used to offer voice services over 5G networks. We will be discussing about IMS in the upcoming videos. Now let us look into security aspects of 5G system. IoT introduces new user equipments with different life cycles, including IoT devices with no user interface, long lifespans during which an IoT device can change ownership several times and which cannot be pre-provisioned. These drive a need for secure mechanisms to dynamically establish or refresh credentials and subscriptions. New access technologies, including licensed and unlicensed 3GPP and non-3GPP, drive a need for access independent security that is seamlessly available while the IoT device is active. High-end smartphones, uncrewed aerial vehicles UAVs, and factory automation drive a need for protection against theft and fraud. A high level of 5G security is essential for critical communication. Expansion into enterprise vehicular, medical, and public safety markets drive a need for increased end user privacy protection. 5G security addresses all of these new needs while continuing to provide security consistent with prior 3GPP systems. Now let us look into some of the key security requirements of 5G system. Authentication. The 5G system shall support an efficient means to authenticate a user to an IoT device. 5G system shall be able to support authentication over a non-3GPP access technology using 3GPP credentials. The 5G system shall support a mechanism for the non-public network to authenticate and authorize user equipments for access to network slices of that non-public network. 5G system shall support operator-controlled alternative authentication methods. Authorization. The 5G system shall allow the operator to authorize an IoT device to use one or more 5G system features that are restricted to IoT devices. Based on operator policy, before establishing a direct device connection using a non-3GPP access technology, IoT devices may use 3GPP credentials to determine if they are authorized to engage in direct device connection. Based on operator policy, the 5G system shall provide a means to verify whether a user equipment is authorized to use prioritized network access for a specific service. Identity management. The 5G system shall provide a mechanism for an operator to allow access from a user equipment using a temporary identifier that hides its subscriber identity. The home public LAN mobile network shall be able to associate a temporary identifier to a user equipment's subscriber identity. The 5G system shall be able to protect subscriber identity and other user identifying information from passive and active attacks. The 5G system shall be able to support identification of subscriptions independently of identification of equipment. For a private network using 5G technology, the 5G system shall support network access using identities, credentials, and authentication methods provided and managed by a third party and supported by 3GPP. Regulatory aspects. The 5G system shall support regional or national regulatory requirements for all supported access networks. The 5G system shall support lawful interception subject to regional or national regulatory requirements. A 5G satellite access network connected to 5G core networks in multiple countries shall be able to meet the corresponding regulatory requirements from these countries. Fraud protection. The 5G system shall support a secure mechanism for allowing an authorized entity to disable from normal operation of a user equipment reported as stolen. The 5G system shall be able to protect user location information from both active and passive attacks. The 5G system shall support mechanisms to protect the production of the user location information and user positioning related data against tampering and spoofing. Data security and privacy. The 5G system shall support data integrity protection and confidentiality methods to serve ultra reliable low latency communication, high data rates, and energy constrained devices. The 5G system shall support a mechanism to verify the integrity of message as well as authenticity of the sender of the message. The 5G system shall support encryption of ultra reliable low latency communication services within the requested end-to-end latency. The 5G system shall enable a mobile network operator to provide end-to-end integrity protection, confidentiality, and protection against replay attacks between a user equipment and third-party application server such that 3GPP network is not able to intercept or modify the data transferred between a user equipment and a third-party application server. Thank you so much for your time. I hope you find this information useful and interesting. Please feel free to subscribe if not yet subscribed. Also, in case if you have not yet gone through the previous videos wherein we discussed about GSM, UMTS and LTE, I highly recommend to watch them. Once again, thanks for your time.